So let's do this. So we already have our matrix, right? Our matrix would be sorry about that. Our matrix is in this form. So that means it's clear CLC, and let's say close all. Then let's define first M1, which is 60 kilograms, M2, which is 70 kilograms, M3, which is 80 kilograms. Then K1 is 50 newtons per meter. K2 is equal to 100 newtons per meter. K3 is 50 newtons per meter. And then let's just assemble the K, where K would be matrix. So you have a row matrix that's K1 plus K2, then negative K2, then 0. Second row would be negative K2, K2 plus K3, and then negative K3. And then lastly, the last vector, or the last row would be 0, negative K3, and K3. Okay. So let's see. Let's try to run. Add to path. Okay. Let's run again. So this is your K vector, K matrix. Then to solve, all you need to solve, so X vector would be K backslash G times M. But what is M? So remember your M vector is this one. So let's define our M vector. M vector would be M1, M2, and M3. As you notice that I use semicolon between M1, M2, and M3 to indicate that this is a column vector. Okay, because if this is a row vector, this operation will have an error. Okay. Of course, we want to also have to define G, which is 9.81 meters per second squared. So this should be our result. Let's run. And this is the result. It's 41.2, 55.917, and 71.613. Okay, so what does it mean? So in this case, if we're going to display our values, let's say x1 would be equal to num to string of the first value. So let's put A, and x2 is equal to num to string of x2 and x3 would be equal to num to string of x, and this is at time e equals 0, the displacements of M1, M2, and M3 are, okay, let me put it here. And let's have another display at the bottom. And this should be respectively. Okay, so let's run. Oh, sorry, num to string. This should be num to string. Okay, so there should be a unit here. Meters, meters, and meters. Okay, so this is now the result of your solution.